In this video, we're going to do our examples for section 5.4, which is Eulerizing and semi-Eulerizing graphs. So for example 3, we're asked to find the optimal Eulerization. So remember, the goal here is to make all vertices even. Now it says optimal, so we want to try to do this drawing as few lines as possible. So let's start with this one because it looks a lot simpler. First thing we have to do is figure out which vertices are odd so that we can make them even. So here we have a 2, here we have a 3, here's a 2, and a 1, 2, 3. So since there's only one odd pair, this is pretty easy. I do want to make sure they're already connected, and they are. So that means I can draw an extra edge in there. And now my degree is 1, 2, 3, 4. So 1, 2, 3, 4. All right, I have all even vertices, and therefore I can find an Euler's circuit. And let's look at this example next. If I get my degrees, there's 1, 2, 3, 1, 2, 3, 4. This one's 2. This one's 1, 2, 3, 4. This one's 1, 2, 3. Here's a 2, 1, 2, 3, 1, 2, 3, and 1, 2, 3, 4. So this is actually the hardest part of the problem. It's just finding your odds. All right, so once I've identified my odds, I want to try to figure out the easiest way to do this. So one thing I probably wouldn't want to do is I wouldn't want to connect these two, because then I can't draw a connection between these two. They're not already connected. And so I want to look for pairs that are kind of already attached to each other. So I'm seeing these because there's a line between them, and then these running straight across. So if I draw in a line, an edge here, that's legal because they're already connected. That bumps those up to 4s. And then I can draw one here, and that bumps those up to 4s, and then I'm done. All right, so now let's go back and do the top. Again, the hardest part is figuring out where all of your odds are. So my corners here will be 2s. And then here I have a 3 and another 3. Here we have 3s. Over here on the left, those are 3s. And down here on the bottom, those are 3s. Now the middle ones, we can see they have 1, 2, 3, 4. And this one, even though it's on a corner, still has 1, 2, 3, 4. And this one has 1, 2, 3, 4. So all of these have 4. So I'm not going to write all those down. They're already even. I want to leave those alone. So I look for my pairs. And I kind of want to pair them up as much as I can. These are very nicely paired for me. So I can just go back. These two are already connected, so I can put another edge in there and make those 4s. I repeat that here, those are 4s. Repeat it here, those are 4s. Repeat it here, those are 4s. Okay, and I have Eulerized the graph. The trickiest one is this one. So if we go through and identify our odds, we can see these corners are 2s, so they're okay. These 6 in the middle are all going to be 4s, so I'm not worried about those. But as I come down the side, here's a 3. So I've got 3s running all the way down till I get to the corner. That's a 2. And I have 3s running all the way across, then a 2 on the corner. I have a 3 here, a 3 here, and a 3 here. So the middle's good. I do need to check these, and it looks like these are all 3s as well. So this one's a little bit trickier because it has a lot of odds. And what the problem is that there's 3 of them in a row. So I have to be a little bit careful. What I can't do is connect these two and then come over and connect these two. See how here to here there's no connection between those? So I can't create a connection that's already there. So let's think about what I could do. If I start up here, I could get these two to match up, and I could get these two to match up. There's already a line there, so I can put that in and make those 4s. And this is just one way to do it. I can put those together and make those 4s. And then I can put these together and make those 4s. Got a leftover one, so I'm going to leave it alone for a second. If I come down here, I can connect these two, and those are 4s. All right, so this one's a bit of a problem. So what I want to do is I want to leave the one that's closest to it alone. So I'm going to connect these two and make those 4s. So now I'm down to this pair. I'm not allowed to come across because there's not a connection there. So what I'm going to do is I'm going to draw an edge from here to the corner. And what that does is that makes this one a 4, but now this one bumps from a 2 to a 3. So now this one's odd. Well, then I can connect these. It bumps this one to a 4, and now this one bumps from a 3 to a 4. So it got 2 new edges, so it went from a 2 to a 4. So sometimes you do have to kind of work your way around to the odds, but you want to do that as few times as possible. So that would be a optimal Eulerization. Now the bottom is going to take us a lot less time because we already have identified our odd vertices at the top. So for example 4, we're going to have the same pictures. See if I can kind of leave that other picture on there. But we're going to semi-Eulerize. So to semi-Eulerize, we want a path, which means we need an odd pair. So we're going to leave one odd pair. Okay, so using my work from up here, I'm just going to identify my odds. I don't really care about the others. And I think on your homework, it indicates which pair to leave. So let's just say it put a star beside these. That would mean to leave that as the odd pair. So when we do our path, we'd start at one and end at the other. So that's the pair we're going to leave. So then we're just going to go ahead and connect all the others. And it's going to bump all those up to 4s. So it will look exactly like your graph from up here, just with one less line drawn in. All right, so if we do the same thing over here, remember that we had a bunch of odds on this one. So I'm going to write all those down. So there's all my odds. So if I can leave one odd pair, if I get a choice, remember this was the pair that gave me the most trouble. So let's leave those as my odd pair. And then just mimic all the connections that we had up here. So we had a line here, which made those 4s. We had a line here, which made those 4s. We put an edge here. We put an edge here. And we put an edge here. So you mimic everything you did up here, but you just leave one odd pair in. So it does take a whole lot less time. So notice I didn't have to do that work around the corner thing there. All right, so let's look at this one. This one matches this one over here. So if I identify my odds, I had an odd here, 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 and here. So I can leave any pair that I want. So I could just take this and remove a line. Now if it identifies which one to leave, like maybe it tells you to leave these, then that just means I need to connect these two. So I could draw a line here and then bump those up to 4s, and that would be semi-Eulerized.